we need to be able to look analytically and get an idea of what's going on that function. We know the parent sine function. We know what it looks like graphically. This tells us the outputs have been stretched to maximums of 2 and minimums of -2. We know that affects our range. This tells us, just this, that we're going through our unit circle from 0 to 2 pi 3 times the rate the parent function is. So we should definitely see a horizontal compression or squeezing or shrinking of that function. This tells us that we are reflecting things over the y-axis. So knowing what's happening to all the pieces of our sine, cosine, and we'll see tangent function helps us realize what changes have been made to our function. So here are the standard forms for sine and cosine. A, the amplitude, affects the range. Makes our highs higher, our lows lower, or it makes our highs not quite as high and our lows not quite as low. It depends on whether A is greater than 1 or A lies between 0 and 1. And again, we're only concerned with the magnitude of measure of A. B affects the period, how quickly we go around that unit circle and pick up those sine or cosine values. C, just like we did before, when we had anything that was inside our function operation. Here our function operations are sine and cosine. There is the inside of them. Whatever's happening there is affecting the horizontal independent variable. Here notice that variable is written as t. That shouldn't bother us. T is just as good a variable as x. Anything that is attached to that independent variable is a horizontal change. Minus is change to the right. Plus is change to the left. We've already discussed why that's true. For trig functions, it's not called horizontal change, it's called phase shift. Any horizontal translation or change on a trig function is called phase shift. So your phase shift is based on what's happening inside your trig function operation. And just as before, whatever's happening out here that's being added or subtracted to your entire original function is a vertical change. That is still true for these trig functions. So this affects maxes and mins. This affects how many highs and lows and zeros that we have. This affects where they occur, because we're picking that function up and we are moving it in the plane to the left or to the right. This also affects highs and lows, because we're picking the function up and moving it up or down. So A controls the amplitude, B the period, C the phase shift, and D the vertical shift. There's amplitude coefficient to the entire function. Here's the period inside attached to the independent variable. Here is the phase shift, the horizontal change to the right or to the left, depending on whether C is a positive or negative value. And here is the vertical change, a vertical shift. So this says determine the amplitude, period, and phase shift of this function. Well, there's amplitude. Remember, it should be a positive value. The period is 2 pi, but we're going through it b times. So the period change is going to be 2 pi divided by b. The phase shift, and you can do some algebra and check me on this if you want to, but the phase shift has to do with how far away from 0 we are and how quickly we're going through the cycles of that periodic function. And it turns out that that happens in that ratio. Do not obsess about memorizing that, because if you are asked to graph something like this by hand, you can go old school and pick angle measure inputs and find corresponding outputs. But remember, I'm going to test you on your calculus skills. You do need to know a certain amount of trigonometry for your pre-calculus exam, but I'll let this cat out of the bag. This is not one of them. Don't obsess about spending hours learning phase shift. The tangent parent function. Things that we know already about the tangent parent function. Again, we're only concerned about this piece. Is the domain is all real numbers knocking out every pi over 2 iteration for every pi along the horizontal axis. And the range is negative to positive infinity. We know that tangent repeats its behavior every pi along the horizontal axis. And we have vertical asymptotes on all values that are not contained in the domain. Please remember we have the identity where tangent is sine over cosine. So we need to ask ourselves, what kind of changes to the graph of the parent tangent function are those two things going to bring about? First of all, this coefficient is going to affect how high our highs go and how low our lows go. However, for the tangent function, we go to positive and negative infinity. So along these vertical asymptotes, we won't really see an appreciable change in the tangent function. What we will see is very near the point of origin. This is a compress, a shrink. We'll see a vertical shrinking of the outputs. This is going to have us going through the period for tangent twice as fast as we normally would. It normally takes input values from 0 to pi to go all the way through this one iteration of the graph of tangent near the point of origin. For this function, it's going to take half that long. We're going to have gone all the way through all of the output values for that one iteration by the time we go from angle measures of 0 to pi over 2. We don't need to go from 0 to pi. It's going to take us half that amount. Notice what's happened here to the changes in your vertical asymptotes. It makes sense that we should reach our first vertical asymptote to the right of the point of origin in half of the length that we do on the parent tan function, and we do. You can plot points, you can sketch and repeat, but you get the idea here that we still have vertical stretching and compressing. We still have horizontal translations, vertical translations. We still have reflections over x-axis or y-axis. But in addition here, we also have some changes in our input values as a coefficient to our independent variable. So it's specific changes to these trig functions. Don't obsess about knowing every single little bit of this. I just want to give you an opportunity, especially those of you that haven't had trig, to kind of see the big picture that tangent, sine, cosine, they're still functions. They still have inputs and outputs. The numbers, the changes, the reflections, the translations still affect these parent functions in a way that we can determine and predict. So it's not just anybody's guess what's going on the graph of these functions. We can look at the function definition and get a very clear idea of what kind of changes are going on our trig parent functions. Look for the next video. We're going to talk briefly about what trig identities I'm going to need for you to know.